So welcome to you. Now we'll see some limit theorems on the function, limit theorems of the function. So before that, we'll see what do we mean by bounded function. Okay. So what do we mean by bounded function? Suppose A is a subset of a set of the real number. Okay. And f from A to R is a function, and C is the cluster point of A. Okay. So we say that the function f is bounded on the neighborhood of C if there exists delta neighborhood of C such that delta neighborhood of C at m greater than 0 such that mod of f of x is less than m. That means all the function values are less than this number for all x belong to A intersection delta neighborhood of C. Okay. So this is the main definition. This is the part here. What f of x is less than. You may say this is less than or equal to m, doesn't matter. Okay. So less than m for all this. Okay. So this is called a bounded function. So if all the functions are that means what, it has the upper bound and the lower bound, right? It has the upper bound and lower bound. Okay. So minus m is a lower bound and a capital M is a lower upper bound of this one. That means what, if the function value lies between A and B, right, then that function is bounded. That means what here, so A is less than f of x is less than B. If such A and B are exist, if such A, this is true for all x. This is true for all x. Okay. So if this happens, then your function is bounded function. Okay. So now, so if the limit, so we will see the theorem now. So the relation between the limit and the bounded function. So if limit exists, then the function is bounded. This theorem tells you that if a limit is exists, then the function is bounded in the neighborhood of C, where C is the cluster point of A. So let A be the subset of R. F from A to R has a limit at x is equal to C. That means C is your cluster point of A. Then F is bounded in some. Okay. Okay. So we prove this one. So prove. Given that limit x tends to C, f of x is equal to L. This is exist. This L. So we'll say this is L. Say we'll say this exist. Okay. So limit is not given. Only I given that the limit is exist. Has a limit means limit is exist. Okay. Okay. So therefore, so limit is exist. That means we can apply the definition of the limit. Therefore, for given epsilon greater than 0, there exists delta greater than 0, such that this is very simple theorem. That means what, if limit is exist, then the function is bounded. Okay. So such that 0 less than mod of x minus c less than delta. So this is what, this is the delta neighborhood of C. This is the delta neighborhood of C. Okay. F of x minus L is less than epsilon. Okay. So this implies that mod of f of x minus mod L is less than mod of f of x minus L is less than epsilon. Okay. So we know that we have seen that this inequality. Okay. Mod of f of x minus L. So this inequality is what we have seen this. This is nothing but what, mod of f of x is less than plus mod L. Okay. This mod L. Okay. So now here see this is what, this is delta neighborhood. We have seen this. Okay. So if you take M as supremum of all f of C, and epsilon plus mod N, then so all f of x are what, less than epsilon plus mod N. So if you take M as the supremum of or maximum of this f of C and epsilon plus mod N, then mod of f of x is less than m. Okay. So therefore f is bounded function. F is bounded function on n delta of C. Okay, so this is for all x belong to A intersection N delta of C. Okay, so this is true for this. Okay, so we have seen the theorem that is if a limit of a function is exist, then the function is bounded. Okay, we have proved this. Now we prove the algebra of the limits. Algebra of the limits. Of the limits. Theorem. Let limit x tends to C, f of x is equal to L, and limit x tends to C, g of x is equal to M. G of x is equal to M. So we will directly written this theorem. Okay, so let A be the subset of R and F from A to R be the function f and g. Okay, and g from A to R be the functions be the functions and C is the cluster point of C. Let limit x tends to C, f of x is equal to L. Limit x tends to C, g of x is equal to M. Then 1. Limit x tends to C, f of x plus g of x is plus or minus we can write L minus M. Second, limit x tends to C, f of x into g of x is equal to L into M. Third, limit x tends to C, f of x upon g of x is equal to L upon M, M not equal to 0. And fourth one, limit x tends to C, k into f of x is equal to k, where k is constant. Okay, k belongs to R, k is constant. Okay, now this is also g of x not equal to 0 for all x belongs to A. Okay, so we prove this one. So proof is also very simple. Let xn be a sequence in A, such that xn not equal to C for all n belongs to n. Now limit x tends to C, f of x is equal to n, and limit n tends to infinity, xn is equal to C. So therefore limit n tends to infinity, f of xn is also L. Okay, is also L. So this theorem we have seen this. Okay, so that is the convergence criteria, convergence and divergence criteria that we have seen. If the limit is exist and xn is a sequence in A which is convergent to C, then f of xn is also convergent to L. So that we have seen. Okay, and we have proved this also. Okay, so therefore limit n tends to infinity, g of xn is also M. Okay, so we'll prove the first one now. So limit n tends to infinity, f of xn plus or minus g of xn is equal to limit n tends to infinity, f of xn plus or minus limit n tends to infinity, g of xn. So this is equal to L plus or minus M. L plus or minus M. Okay. So therefore limit x tends to c f of x plus g of x plus or minus L plus or minus M. Plus or minus M. Okay. So this we have proved the first one. Okay. The second one. So this is the first one. Okay. This is the first one. Second one. So second one is the product. Okay. Limit n tends to infinity f of xn g of xn is equal to limit n tends to infinity f of xn into limit n tends to infinity g of xn, and this is L into M. Okay, so therefore f of xn into g of xn tends to Lm, right? So therefore f of x into g of x tends to Lm. It also tends to Lm. So therefore limit x tends to c f of x into g of x is equal to Lm. Is equal to Lm. So this is very simple. This is with the help of the sequential criteria. So we have to do this algebra of the limits. Okay. So third one, limit n tends to infinity f of xn upon g of xn is equal to limit n tends to infinity f of xn upon limit n tends to infinity g of xn. This is L upon M. Okay. So therefore f of xn upon g of xn tends to L upon M. So therefore limit x tends to c f of x upon g of x is L upon M. Okay. And the fourth one, limit x tends to limit n tends to infinity k into f of xn. This is what? K into limit n tends to infinity f of xn. Okay. And this is equal to kl. So therefore k into f of xn tends to kl as n tends to infinity. So therefore k f of x tends to kl as x tends to c. As x tends to c. So therefore limit x tends to c k into f of x is equal to k. Okay. So this is the algebra of the limit. So what algebra of the limit? Limit of the ratio is same as the ratio of the limit. Okay. Product limit of the product is the product of the limit. So limit of sum or difference is the sum or difference of the limit. Okay. So if you multiply by the constant to the function, it is independent on x. It is independent on x. You can take the outside of the limit. So that is what k into limit of the function. Okay. So this is the algebra of the limits. So we have proved with the help of the sequential criteria. Now this is the important theorem, that is the quiz theorem. So the proof is not there. Quiz theorem. Quiz theorem. Quiz theorem. Okay. So statement. Let A be the subset of R. Let A be the subset of R. F, G, H are the functions from A to R. These are the functions from A to R. And let C belong to R be the cluster point of A. Be the cluster point of A. If f of x less than or equal to g of x less than or equal to h of x for all x belong to A, then for all x belong to A and x not equal to C, and x not equal to C, and if limit x tends to c, f of x is equal to n. This is same as limit x tends to c, h of x. So f of x and h of x have the same limit. Then limit x tends to c, g of x is also n. This is also n. So that means what? If a function g of x is a function lies between f of x and h of x for all x belong to a and x is not equal to c, and if the limit of f of x and h of x are same, then limit g of x is also same as n. This is the quiz theorem. We'll apply somewhere. Okay. So we solve problem with the help of this one also by using the quiz theorem. Okay. So we'll form a function, two functions such way that so that function lies between the two functions where their limits are same, so that the limit of your original function will be the whatever that limit of the f of x and h of x. Okay. So we have to find such a function f of x and h of x. Okay. So this is very important theorem. So we'll not prove this one. Next, what do we mean by left hand limit and right hand limit? Okay. So left hand limit. Left hand limit. Okay. So x tends to c minus. It is denoted by x tends to c minus. Means what? X is less than c. Means what? X than c. So we write this as limit x tends to c minus f of x, and this is what? The left hand limit. This is read as left hand limit is what? Limits x tends to c minus f of x. So right hand limit is what? It is denoted by x tends to c plus. Note that the c plus and c minus, they are the symbol only. This plus and minus are only the symbol. Okay. So this implies that x is greater than c. That means what? Here c is there. So x tends to c. This is from right hand side. Okay. So this is called as a right hand limit. If your x approaches from right to left now. So now from here, so this is what? Left hand limit. This is your x. This is your left hand limit. So see here, it is the left. All x are left to the c. So that means all x are less than c. Okay. So this is what x is. Where is the x? X is on the right hand side of the c. And you know that the number right hand side is the biggest number. Okay, is the bigger number. So that means what? All the x are greater than c. All x are greater than c. So this is the right hand limit. Okay. So this is greater than c. We write this as this as limit x tends to c plus f of x. That is what? Right hand limit. Okay. And limit is exist. Limit x tends limit. We write this as limit x tends to c, f of x is exist if limit x tends to c plus f of x is equal to limit x tends to c minus f of x. So if left hand limit is exist, right hand limit is exist, and they are equal, then we say that limit x tends to c f of x is exist, and the value of this limit is same as the whatever this. So that is what? Limit x tends to c f of x is equal to limit x tends to c plus or minus whatever this is. Limit x tends to c minus f of x. Okay. So if limit right hand limit is exist, left hand limit is exist, they are equal, then we say that the limit x tends to c f of x exist, and the value of limit is what you get from this. Okay. So that will be your value of the limit x tends to c f of x. So suppose what if you want to find, this is what sum of x tends to 0 here, and if you want to find mod of x upon it. Now see here, you know that if x is negative, that means if x is less than 0, then mod x is minus x now. Okay. Now see, for x less than 0, your function change. X greater than 0, your mod x will be the x then. Okay. So for x less than 0 and greater than 0, you see that the function change. the value of function changes, right? So that means what, here you have to find the left hand limit and right hand limit. So if left hand limit is same as right hand limit, then we say that this limit is exist. So to evaluate such type of the limits, you need to find the left hand limit and right hand limit, because what, the function value change. So mod of x is minus x if x is less than 0. So that means if x less than 0, the function change. X greater than 0, the function change. That means you have to take the left hand limit and right hand limit. Okay. So these are the theorems of the limit. So we'll take a problem in the next session. We will take the problems on it. Okay. So now we'll stop here. Thank you.